All right, so related rates part 2. Basically, all of these examples are going to be dealing with right triangles. So the main thing that we need to remember here is not any kind of geometry formula, but mainly just the Pythagorean theorem. So let's just jump into some examples here. All right, so we got a ladder 10 foot long leaning against a wall. So let's say we have a wall here. We'll assume that the ground is perpendicular to the wall, so it forms a right angle here. And the ladder is 10 foot long, leaning against the wall. The base of the ladder is moving away from the wall. So here's the base of the ladder. This is moving away from the wall. All right. So let's try and make that arrow a little bit more like an arrow. So we have a ladder that's, kind of like the ladder's falling down. So the base of the ladder is moving away from the wall at a rate of 0.5 feet per second. So we need to start off by giving some variables here. So let's just call this x. Let's call this y. You can call this whatever you want to. I don't know, call it z, whatever. So if it's moving away from the wall at a rate of 0.5 feet per second, that rate is relating to x. So that's going to be dx with respect to time dt. And that is a positive because it's moving to the right. If you think of this in terms of like your xy plane, like this, if you think of this as like your xy plane, that's moving to the right, so that's going to be positive. That's kind of how I think of it. So that's going to be a positive 0.5. How fast is the top of the ladder sliding down? So this is sliding down, so we need to find dy dt when the bottom of the ladder is 6 feet from the wall. So that's x is 6. All right, so we can start here. So again, we're dealing with a right triangle. So the formula, like I said, is not a surface area, volume, anything like that. The only formula we know that deals with right triangles is the Pythagorean theorem. So x squared plus y squared is equal to, you could say z squared, but since the height of the ladder is not changing, this ladder is always 10 foot long, we can just say 10 squared. All right, so now we're going to take the derivative. So the derivative of x is 2x dx dt. This is with respect to time, so dx dt, plus 2y dy dt equals, and now the derivative of 10 squared is just 0. Okay, a lot of times people see that and they think power rule and they want to bring the 2 out. But there's no variable, there's no x's in here. This is just a constant, so that derivative is 0. All right, I'm going to divide everything by 2, so I'm going to just get rid of these 2's. We don't need to worry about them. And then you can realize here that when we start to plug some numbers in, kind of like yesterday's, but not nearly as much work, but kind of like yesterday's, we're missing some stuff. So I have x is 6. I know dx dt is 0.5. I'm looking for dy dt. That's what I'm trying to find, but I don't have a number for y. So how do we find out what y is? Well, I have a right triangle here, and like we said, we're using Pythagorean theorem, so y squared plus x squared, well, x is 6, so 6 squared is equal to 10 squared. So Pythagorean theorem, however many steps that takes you, you should be able to figure out that y is equal to 8. All right, so now we're ready to plug numbers in. So x is 6, dx dt was 0.5, plus y, we just solved for that, was 8, and dy dt is what we're looking for, equals 0. So 6 times 0.5 is 3, plus 8 dy dt. Again, as many steps as it takes you to get dy dt by itself, we can realize that dy dt in an exact answer would just be negative 3 over 8. And if we're rounding that, well, actually, we don't even need an approximate symbol here because this only has 3 decimal places. So this would just be negative 0.375. And I'm actually going to move this all over so I can fit units in here. So the units for this dy dt, the units were feet per second. Okay, and now we got a negative, so let me just clarify why we got a negative. All right, so negative 0.375. So if we look up here, going back to the this being the coordinate plane, negative numbers go down. The ladder, the top of the ladder was falling down. So if you think about when we're going down the y values, that's like your negative numbers, you're subtracting. So just think of that. If these vertical numbers are going down, those should be negative. If they're going up, they should be positive. And for your x values, if they're moving to the right, they should be positive, and if they're moving to the left, they should be negative. Okay, so just think of that in terms of like your coordinate plane. It kind of makes sense, and it just kind of helps to bring that into perspective. All right, next one, very similar type problem. So what I would suggest you do is pause it, try this problem on your own, and then come back and see if you have the same answer that I get. All right, so ladder is 13 feet. I'm going to use my same variables x and y here. Okay, so the top of the ladder slips down the wall, so it's falling down the wall at a rate of 2 feet per second. So dy dt is not equal to 2. It's falling down. That's a negative 2. Okay, so again, don't forget those little keywords that tell you whether it's positive or negative. How fast will the foot be moving away from the wall? So we want to know how fast is this moving. So we're trying to find dx dt when the top is 5 feet above the ground. So when y equals 5. Okay, so y squared plus x squared, we're going back to Pythagorean theorem, equals 13 squared. Take the derivative, 2y dy dt plus 2x dx dt equals the derivative of 13. Again, it's just a constant. That's 0. And again, we realize we have a similar problem as we had in that last one. We have y, we have dy dt, we don't have x. Same thing that we did in the last one. We need to y, so we're going to use Pythagorean theorem, 5 squared plus x squared equals 13 squared. So x equals 12. Sometimes you do get nice numbers like this, but sometimes you end up getting square roots, and we just leave them as square roots until our final answer, and then we round. You don't want to round your square roots to 3 decimal places. You want to, if you do end up getting a square root, like you'll see in the next problem, leave them as square roots until your final answer. You want to try and leave them exact until your final answer. But same thing like the last one, we can get rid of these 2's, divide everything by 2, 0 divided by 2 is just 0, so help us to simplify things a little bit here. All right, so y is 5, dy dt is negative 2, plus x we now know is 12, and dx dt is what we're trying to solve. All right, so again, multiply, move stuff around, we end up getting dx dt is equal to 10 over 12, which again, rounded to 3 decimal places. We end up getting, this is going to be a positive one now because, again, we're looking at the base of the ladder moving to the right away from the wall. So this one will be an approximate 0.8 and then 3 repeating. So if we're going 3 decimal places, we just need 2 3's. And I believe we're still in feet per second. Okay, so hopefully you got that for your answer, and if not, hopefully you can figure out what you did wrong there. All right, last one. A baseball diamond is a square with sides of 90 feet long. So all of the outsides, it's a square, so all the sides are the same, 90 feet. So we want to suppose that a player is running from second base. So this is second base. They're running from second base to third base, down to here. And they have a speed of 30 feet per second at the instant that he is 20 feet, so we'll say somewhere in that area, from third base. At what rate is the player's distance from home plate changing at that instant? So we are now looking at a comparison, still doing a right triangle. A comparison is this person from, trying to make that a dotted line, a comparison as from this person to home plate. That was terrible. Let's try it one more time. Not much better, but anyway, you can see there, that's the right triangle that we're looking at, okay? Now we're looking at, as this person is going, it's a good idea to think about what your answer should be from the beginning. As they started out here, their distance from here to home plate, whatever that is, I forget what the distance from home to second base is. Let's just say it's 100 feet. As they're moving to third base, that distance is decreasing. So keep in the back of your mind, your answer should be a negative number, okay? So let's see what we have here. Let's label some things. I'm going to call this Y, and I'm going to call this X. No, I'm not, because I don't need a variable over here, because I already know that this over here is always 90. I'm going to call this H, because that's my distance from the person to home base. Okay? So now when I set up my Pythagorean theorem, I'm going to say y squared plus 90 squared is equal to h squared. Okay, so let me back up a step. Suppose that a player running from second base to third base has a speed of 30 feet per second. So that means my dy dt is equal to 30. Now, again, the way this looks right here, it may be difficult to see whether that's positive or negative, but that is going down towards the origin, so that should be a negative. At the instant when he's 20 feet from third base, so that means this space, this distance right here is 20. So when y is equal to 20, and we want to know at what distance, or I'm sorry, at what rate is the player's distance. So we're trying to find my variables that I have here. We're trying to find dh dt. Okay, you could use different variables if you want to. Okay, when we do the derivative, you're going to find out we have a similar problem as to what we had in the last two examples. I don't have a problem with 90 because the derivative of 90 is 0. 2h dh dt. But you can see here's the problem. I know y is 20. Let me back up a step. Again, divide by 2. Gone, gone, make it easier. So y is 20. dy dt is negative 30, right? That's good. H, I don't know. dh dt is what I'm trying to find, but I don't know h. So I have to come back to my Pythagorean theorem again. And I know y squared plus 90 squared is equal to h squared. Y is 20, so 20 squared plus 90 squared, squared, equals h squared. So h in this problem is the square root of 8,500. Okay? Let me double check that. Yeah, 8,500. Okay? Now, I'm going to leave it like this. This is what I was saying before. I'm going to leave it like this in the problem. For my final answer, I'll round it in my final answer. But when I'm doing the problem, I'm just going to leave it as square root of 8,500. Okay? So h, I'll plug that in later. So y is 20. dy dt is negative 30. Equals h is the square root of 8,500. Okay, we don't have any problem plugging that into our calculator, so there's no reason for us to round it. dh dt. All right, so negative 600 divided by square root of 8,500. That's an exact answer, but of course we don't need that. We want to plug that into our calculator and see what we get. So dH dt is approximately, and again, we're going to get a negative answer like I explained before. The distance that when they're going from second to third base, their distance from home is decreasing. When they're at second base, they are the furthest that they are away from home. And when they get closer to third, their distance from home is decreasing, okay? So this should be a negative number, and it is a negative number, okay? We have negative 600 over a positive. So, oh, my tablet shut off. Give me a second. Come on, I got one more number to write here. Don't quit on me. All right, so last, there we go. So the final answer here, negative I got negative 6.508 when we round to 3 decimal places, feet per second. Okay? So again, all of these had to do with Pythagorean theorem and right triangles. Yeah, so if you have any questions, watch the video again, watch the examples again, try the examples in the worksheets, and just send me an email and let me know if you have any questions on any of those problems or any of these problems here in the notes.